All right, I'm looking at our fourth learning target, and it's really, calling it a learning target, it's really like our fourth skill that we really need to be successful in this unit. And we know we'll have to put a lot of these skills together as we've been doing pretty much every day in class. So that shouldn't be new to us either. But we are going to have to evaluate a function using function notation. And I just put in parentheses, write those values in a table. Like, you know how to make a table. That's not a new skill. The word evaluate in this context, that means we're going to find the value of, or I could think assign a value to. So in 4a, this first example for number 4, I could think of this as just a function in function notation. This might jump out to me as we've also called this like an explicit rule. And if I really feel confident in what I'm doing, I might be able to tell from the structure of that equation or structure of that rule that this is arithmetic. And if you can't tell that yet, like, that's okay. I know function notation can feel a little bit overwhelming at first. All right, so when I evaluate f of 1, I'm going to take this function, and everywhere I see the letter n, I am just replacing it with the number 1. That's all I have to do first. So f of 1 is 18 minus 2, and then in parentheses, 1 minus 1. All right, now using the order of operations, I know you learned PEMDAS, or please excuse my dear Aunt Sally, I'm going to call it GERMDAS. That G stands for grouping, because really when we say parentheses, we mean anything grouped, and we don't always use parentheses for that. And the R stands for radicals. All right, so when I plug the 1 in, I know I do need to do what's in my group first. I'm going to subtract. So that becomes 18 minus 2 times 0. And then don't forget, I multiply before I divide. So when I'm evaluating, I'm moving this way through the order of operations. So that becomes 18 minus 0, which is just plain old 18. All right, so I get 18 for that first term. All right, when I find f of 2, oops, all of a sudden my pen's not cooperating with me. When I find f of 2, I do the exact same thing, except instead of plugging in a 1, I plug in the number 2, or substitute the number 2 for n. So 18 minus 2 in parentheses, what number did I just say? I'm plugging in the number 2. 2 minus 1. So again, it's only where I see n that I substitute a 2. All right, again, following the order of operations, I'm going to do what's in my group. 2 minus 1 is just the number 1. I know 2 times 1 is 2, so this is 18 minus 2, aka 16. All right, I kind of spoiled it earlier when I said this is arithmetic. I would encourage you to keep evaluating to fill out the table, although it appears I didn't actually leave you that much room on your paper. I'm just going to do one more. So when I plug in the 3 minus 1, that becomes 18 minus 2 times 2, which is 18 minus 4, which is 14. And again, I could probably tell by now that this pattern is decreasing by 2, or this sequence rather is decreasing by 2. So my next term should be 12. So just notice real fast a few things. I know we've talked about this in my class a lot, but notice that 18 was our first term, and also notice that we had n minus 1 in parentheses. That's not a coincidence. We've talked about that a little bit. And then I would also point out the multiplier, that negative 2 rather. I'm going to think of that as a negative 2. That is in front of my expression that involves n. So when I say my expression that involves n, I mean that n minus 1. That ends up being our constant difference, or sometimes we call this a constant rate of change, and we'll talk about that a lot in our next unit. All right, 4b. Oh, this one looks different, similar but different, but you know what? I'm going to start this off the exact same way. you might recognize this as being geometric. And if you don't yet, that's okay. So f of 1 is 24 times 1/2. And because that n minus 1 is really small up there, that's an exponent. So it's like in our subscript, 1 minus 1. All right, remember how I just said a moment ago that I use GERMDAS because we don't always have parentheses when we have grouping. So if I have, for example, n minus 1 as an expression that is an exponent, that really is something I have to do first. That n minus 1 is grouped, so the parentheses are kind of implied, even though they weren't actually written there. So I need to do that first. I know that can be frustrating about the order of operations. All right, so this is 24 times 1/2 to the power of 0. Okay, because I did 1 minus 1 and that became 0. And we've discussed this briefly in class, but we said that any non-zero number to the power of 0 is in fact 1. And that is something you learn in middle school, but I do understand that we don't always remember everything we learn, so that's why we review. All right, so I know that I want to evaluate an exponent before I move on to multiplication. So 1/2 to the power of 0, we just said is going to be 1 because 1/2 is not 0. So this is just 24 times 1, which is 24. All right. Okay, we'll just do a couple more and then I bet we'll see that pattern if we don't see it already. All right, so when I evaluate f of 2, again, I'm going to take my expression for f. Maybe I should have highlighted that to help us see it. I'm going to substitute 2 anywhere I see n. So 24 times 1/2 raised to the power of 2 minus 1 now. And so again, 2 minus 1 is just 1. So that just becomes 24 times 1/2, which is 12. All right, let's just do one more and make sure we see what's going on here. All right, f of 3 is 24 times 1/2 to the power of 3 minus 1. So 24 times 1/2. I'm going to do that subtraction to the power of 2. Uh-oh. Oh no, I have to square a fraction. Now you could do this in your calculator, but remember 1/2 squared is just 1/2 times 1/2. And hopefully we remember that when we multiply fractions, we multiply the numerators together, so 1 times 1. We multiply the denominators together, 2 times 2. So we just get 1/4 there. I think multiplying fractions and dividing them is much easier than adding or subtracting, because while we can use a strategy that involves common denominators, we really don't need them. All right, so now since 1/2 squared is 1/4, I get 24 times 1/4. We said we could turn that into division by using the reciprocal, so that is going to be the same as 24 divided by 4, or I could just think of this as 24 over 1 times 1/4 and multiply that like two fractions. So the numerators give me 24, the denominators give me 4. Now I see that division. My quotient is 6. All right. Oh, you might have noticed I mentioned it was geometric. You might see the pattern, I hope you do see the pattern, that each time n increases by 1, my values of f, or value of f, is half of what it was before. So that's our common ratio. So I should have a 3 here, and you could also evaluate f of 4. So again, kind of what we saw in the arithmetic example above, I just want to point out that our first term is 24. I see that here, but I also see n minus 1. And it's I don't know, this is an important connection, but we're going to build on this connection. All right, and then we said our common ratio is a half. You might see this as division by 2, and I get that, but division by 2 is multiplication by 1/2. So remember, you can always turn division into multiplication by writing a number as its reciprocal. We define reciprocal as, I'm going to write it out here. Reciprocals are two numbers that have a product of 1. So for example, the number 4 and then the number 0.25 are reciprocals because they have a product of 1. You may also recall, though, 0.25, I could write that as 25 over 100, but that would be the same as 1/4. And the reason I love fractions for reciprocals is you can just literally flip the numerator and the denominator. So like if I have 2/5, my reciprocal is 5/2. So I could divide by 2/5 or multiply by 5/2 and I'll get the same solution. All right, we've talked about that a fair amount in class this unit. All right, 4c, use the function f of n equals 4 times n, 2 to the power of n to evaluate. I noticed that this looks like 4b. It might be easier because I don't have a fraction, but I'm also noticing that this doesn't have an n minus 1. So I wonder what that might, how that might be interesting. I guess we'll find out. All right, we're going to evaluate this real fast. F of 1 is 4 times 2 to the power of 1. Again, order of operations. I don't really have grouping here. Those parentheses are just to indicate multiplication. I do have an exponent though. 2 to the power of 1 is 2. So this becomes 4 times 2, which is 8. Let's see. Oh, excuse me. Sorry, I'm not feeling well. All right, f of 2, when I plug in a 2 there, I've got 4 times 2 to the power of 2, or we could call that 4 times 2 squared. So I do my exponent first. 2 times 2, or 2 squared, is another 4. 4 times 4 is 16. I'm trying not to use a calculator, but you are welcome to use a calculator. On this assessment, you will be allowed a calculator. All right, f of 3. 4 times 2 to the power of 3. So I know 2 to the power of 3, or we call that 2 cubed. We could expand that. Think of that as 2 times 2 times 2. So 4 times 2 times 2 times 2 is 4 times 8, and that is 32. Oh, now I'm noticing a pattern here. I said that this one also looks to me like it's geometric. To be fair, I've had a lot more time than you have to get really good at geometric sequences, but I'm betting you my next term is a 64, and if you check me by evaluating f of n, I sure hope I'm right about that. Now, what I want you to notice here, that you may have noticed without me telling you to notice it, this 2, that thing that's being raised to the power, in this case of n, that's our common ratio. That is the number by which we are multiplying to get from one term to the subsequent term. When I say subsequent, I mean next in a sequence. That is a word we use both in and outside of math. Or you could just say the next term. They mean the same thing. All right, so I'm multiplying by 2. Now, what I also notice is that the number 4 that is right here is not actually in my table. But in the problem above this, or the example above that looks so similar, the 24 was in our table. That was our first term, and we also noticed we had n minus 1 here. What I'm wondering about is, what if I thought about this n as n minus 0? And could that mean that that 4 is what f would be if n was 0? And I realized that in a sequence, it doesn't really make sense to have a 0 term. Like we start with the first term, but I know we've done this in class. I'm just going to make another space and put in a 0. If this pattern continues, I would indeed have a 4 there. So that 4 times 2 is 8. So that's not a coincidence. In fact, we're going to talk about that a lot more in our second unit as well. All right, and that's also another strategy to help us write explicit equations is find f when n is 0 or find y when x is 0.